Two cars leave an intersection simultaneously. One heads north at 45 miles an hour and one heads east at 35 miles an hour. And we're assuming that they're going at a constant speed. Here's north, here's east, here's car 1, and here's car 2. It's a little bit slower. Okay, we want to know the distance between them. We'll call it D. Here we have a right triangle, so if we could find these distances, we can find D. Well, there's a formula that relates distance and rate and time. Hopefully you have it memorized. Distance equals rate times time. So for car 1, our rate is 45 miles an hour, and our time is just going to be t. And then car 2 would be 35t. Alright, let's use the Pythagorean theorem to find this distance here. So Pythagorean theorem says that a squared plus b squared equals c squared. So 35t squared plus 45t squared equals d squared. 35 squared is 1,225. 45 squared is 2,025. And let's add these terms together, and we get 3,250 times t squared equals d squared. And we're trying to find d, so let's take the square root of both sides. Square root of d squared is the absolute value of d, but d is never negative because it's a distance, so I can just put d. And same thing with t. Square root of t squared, I can just put t. 3,250 is 25 times 130. So when we take the square root of that, we have that perfect square. We're going to get 5 times the square root of 130. Since this is an application, let's label the units. Our rate was in miles per hour, so distances are going to be in miles.